Today we're going to look at restrictions and canceling for rational expressions. So whenever we have a rational, remember that just means it's a fraction, right? So a fraction is just a number over a number. And we know that there is a number that exists that we cannot divide by, right? That bottom number can never be equal to 0. So if our bottom number is going to become 0, then we would call that a restriction. That would be when the function is undefined. Yeah, it's not allowed. You can't divide by 0. So in here, if I've got 7 over x, I would know that x can never be equal to 0. It can be any other number, but it cannot be 0. Same thing if I now have, oh goodness, what do I have underneath here? I have an m plus a 2. So I know my denominator cannot equal 0. And we know how to rearrange equations, right? If this is a plus, we're going to minus the 2 from both sides. So that means that the letter, my variable, can never be -2. It can be any other number, but it cannot be -2. Same thing if I get it even more complicated. So remember, if I have 0 times any number, my answer is always going to be equal to 0. So when I have it factored like this, then I need to make sure that neither one of these sets of brackets is going to become 0. So that means I need to make sure that x plus 2 does not equal 0. And it means that 3x minus 1 cannot equal 0. Rearrange them all, figure out what the letter actually means. So instead of plus, we're going to have a -2. Right? We're going to do the opposite. So x cannot be -2. And for the other bracket, let's see, we got to move that 1 to the other side. Instead of minus, it's now a plus. So that gives me 3x cannot equal 1. Divide both sides by 3. And x cannot be a third. Oops. So these are all restrictions. And they all affect the graph in different ways, but we'll worry about that another time. Today we'll just worry about the algebra. So another important thing when it comes to fractions is canceling. So let's look at a couple of just straightforward numbers first. So when I've got my numbers, I've got a 2 times a 5 over top of 2. We know if we have the same number in the numerator as the denominator, we can cancel it out. So that would leave me with just 5. Let's look at the other one. If I have a number in the bottom and it goes into the number up top, so 4 goes into itself once, 4 goes into 8 twice, well then I would be left with 2 times 3. Which in this case, they're both numbers, so I can make that equal to 6. Okay, let's start putting in some polynomials in there. So here I've got some letters. Hey, this is kind of like what we did yesterday, isn't it? So let's see. Oh, and I've got a 3 and a 6. All right, let's just take all this magic out. 6 we know is 3 times 2, and then that x. And in the bottom, I've got my 3 times my x. So what's in the same top and bottom? 3 goes into itself, x goes into itself. So I'm left with an answer of 2. How about down here? I've also got it factored. So I've got a 3 in the bottom and a 3 up top, so they cancel out. I can't cancel anything else, so we're done. So my answer is going to be the x plus the 5. And that's it, you're done. Okay, how about the next one? Let's see. 9 goes into itself once. 9 goes into 18 twice. So we are left with x minus 1. How about here? Here I've got a 9x over a 6x and a bracket x plus 2. Now one thing that we really got to emphasize here is that this bracket here travels together. You cannot split it up. Cannot split it up. So that means when I go to cancel, I can cancel this 6. So 3 goes into that twice. 3 goes into the 9 3 times. I can cancel my x, so this x goes into itself and this x goes into itself, but I cannot take out the x from inside the brackets. You can't split it up. Not allowed. Nope. So you have a 3 up top, and you have this x plus 2. It travels together. And underneath, what are we left with? The 2. Okay. What about a bigger looking one like this? So our goal is going to be, we're going to be ending up with all these lovely polynomials, and we're going to have to factor them. So our goal is going to be to get something like this, so we can cancel only one fully factored. So you have to get your numerator and your denominator to look something like this before you can start canceling. And then you start looking for matching pairs. So if I look in here, let's see. This x minus 1 is the same as this x minus 1, so they can cancel. This x plus 2 is the same as this x plus 2, so I can cancel the full bracket. You cannot bust it up. It's got to be the full bracket. Full bracket. Okay, say that to yourself. Full bracket. And then let's see, we've got a 2 and a 4. 2 goes into itself once, 2 goes into 4 twice. So what's left? Well, we canceled these guys off. And we canceled these guys off. So I'm just, 1/2. There it is. Oh, but I had x's in the denominator too, didn't I? Well, as soon as we have x's in the denominator, we got to worry about those restrictions. So that x plus 2, I know we got rid of it, but it still is not allowed to be equal to 0. So x cannot be -2. And yes, I know we got rid of the x minus 1, but it still can't be equal to 0, which means x is not allowed to be 1. Okay. Let's look at these ones. I have a 4 plus 12 over 4. I mean, whoever writes it like this? Nobody does. But just for the sake of our conversation, let's look at it with just our plain old numbers here. So I know 4 goes into itself once, and 4 goes into 12, doesn't it? So let's common factor out our 4. So let's see, 4 goes into itself once. 4 goes into 12 3 times. So if we common factor, hey, look, now I can see very easily 4 goes into itself. Notice we are fully factored here. And then what's left? 1 plus 3 up top. Okay, same idea when we've got the letters. All right, let's look at the numerator. 3 is common to both. M is common to both. Open up our bracket, what's left? 3 goes into 6 twice. M goes into m squared, so I still got one more m. Plus, 3 goes into itself once. M goes into itself once. Close off my bracket. Denominator, I'm just going to change the order so it looks the same as up top. Now that I'm fully factored, now I can cancel 3 with the 3, m with the m, nothing else cancels. That whole bracket travels together, 2m plus 1. Because I had an m in the denominator, I do still have a restriction. So 3m cannot equal 0, which means m cannot equal 0, right? Because 0 divided by 3 is just 0. Should we write that in? Eliminate the secrets, right? Divide both sides by 3. M cannot equal 0. Okay, let's do one more. Fully factor. So let's see, a squared minus x 16 squared. Oh, that's a difference of squares. Difference of squares. Square root of a squared is a. So I put an a in the front of both my brackets. Square root of 16 is 4. One set of brackets gets the plus, the other one gets the minus. Let's look at the denominator. 3 goes into both, so let's common factor. 3 goes into 3a, so I've got an a, plus 3 goes into 12 4 times. Now remember, they have to match the bracket fully if I'm going to cancel a full bracket. So a minus 4 and a plus 4 are not the same thing. So a plus 4 matches. So they have to travel together. A minus 4 is its own thing. So you can only cancel if the full bracket matches. So a plus 4 cancels with a plus 4. So what am I left with? A minus 4 up top, 3 in the bottom. Yes, I know it canceled, but it's still a restriction. Because it was still part of the original function. So a plus 4 canceled, but it still cannot equal 0. Bring the 4 to the other side, so we're going to minus our 4 from both sides. So a is -4. Sorry, a is not -4. Not. Okay. Where am I at? Okay. So there's the basics of what we're going to do. So I'm going to pull out those examples from the textbook too, and let's see what they look like. We want to write the simplified expression for this big, ginormous looking thing. Oh my goodness. Oh, don't panic. Don't panic. One piece at a time. Look at the numerator. 3 is common to both. I have an n to the exponent 3, n to the exponent 2. So take your smallest exponent, so they each have a 2. So we've got an n squared. Who's left? If I took 2 out, 1 is left. Minus, I took out the 3, I took out the n squared. I took everybody out. So it's a 1. All divided by, let's see, always look for a common factor first. Oh, 4 goes in everything. Oh, and n goes in everything. Okay, let's take out a 4n. Who's left? 4 goes into 8 twice. N goes into that n squared. Minus 4 goes into 12 3 times. N goes into n squared, so I've got an n left. Plus 4 goes into itself once. N goes into itself once, so we're done. All right. Is there any more factoring that we can do? Well, let's think about this here. I'm going to use a different color, so I'm just going to factor this guy off to the side. So let's see. I've got 2n squared minus 3n plus 1. So I need 2 numbers. It's a trinomial here. There's 3 of them. 2 numbers that multiply to equal 2 times 1. Right? First times my last. And I need those same 2 numbers to add to equal my middle, which is negative 3. Oh, well, there's not really any option here, is there? We're going to have a 1 and a 2. And a 1 and a 2. And they each need to be negative to make a negative 3. And if they're both the same sign, it's going to come out positive. Okay, we're good. So keep the first term, split the second term. So there's my minus 2n, minus 1n, and then there's my plus 1. And then we look at the first 2, and we common factor just the first 2. So 2 goes into both, n goes into both, new bracket, n is left, minus 2n goes into 2n once. Now common factor the second 2. Negative 1, let's take out a negative 1. Who's left? N, I took out a negative, so that becomes a minus 1. Do my brackets match? Yes, they do. Excellent. So n minus 1 is common to both. New bracket, what's left? 2n minus 1. Okay, good. Now let's stick that back over here. So my numerator is still 3n squared bracket n minus 1. Denominator is 4n out front. And then let's put this guy in. So I've got an n minus 1 and a 2n minus 1. Cancel anything that matches. Does anything match? Let's see. Let's see. This bracket is an n minus 1. Do I have one? Oh, I do. I do. So I can cancel that guy all out. Is there anything else I can cancel? 3 and 4, they don't really cancel. Oh, but I can cancel out one of the n's. And I canceled out that one. So who's left? Let's see. I have a 3n up top. Everything else is gone. And underneath, I have the 4 gone, 2n minus 1. 2n minus 1. Leave the answer in factored form. This is enough. But let's definitely state our restrictions. So for our restrictions, we're going to go back to this row right here, our fully factored row before we started canceling. So this way we don't forget anything. So let's go through it. We've got an n, so n cannot equal 0. We have an n minus 1, so it cannot equal 0. Bring the 1 to the other side. So plus 1, n cannot equal 1. And then our last one, 2n minus 1 cannot equal 0. Oh boy, plus 1 to both sides, 2n equals 1, divide both sides. N equals 1/2. So we had 3 restrictions there. Oops, not equal. Not equal. Good. Let's get example 2. Here we have a nice one. Oh, we did this sort of thing yesterday, didn't we? Here we go. We just got to simplify. So who divides into what? So let's see. 6 goes into itself once. 6 goes into 35 times. And I've got 4 x's up top and 7 of them down below. So remember our rules if you don't like my canceling. When we are dividing, that means that we are subtracting our exponents. And if I have a negative exponent, to make it positive, it has to go into the denominator because it was up in the numerator. Now it's in the denominator. So that means that the 4 of these cancel out and I'm left with 3 of them down below. And I've got 1y there, and I've got 3y's up top. So I got y to the 3 divided by y to the 1. Subtract your exponents. And I'm left with a squared, so it's left up top. So this 1y knocks out two of those, or one of those. So I'm left with y squared up top. So my final answer would be 5y squared over x cubed. And don't forget I had this negative, so the whole thing is negative. And our restrictions, let's not forget restrictions. So look back at our denominator. So remember our denominator was negative 6, x to the 7, y to the 1. So this can't be equal to 0, which means, well, negative 6 is just negative 6. X to the 7 cannot equal 0, which means x can't be 0. Y to the 1 can't be equal to 0. Well, y to the 1 is just another way to say y. So my letters can't be equal to 0. Okay, next one. Let's do some simplifying stating any restrictions. So that means we're going to factor if we can, cancel what's available. So we can't really factor the denominator at all, but let's see if we can common factor up top here. Always look for common factor at first. 4, 8, 10. Oh, they're all even numbers. So 2 will go into all of those. So I'm going to take out a 2. And I've got 4x's, 2x's, and 1x. So 1x can come out. 2 goes into 10 5 times. X squared comes out, so 3 of them are left behind because then they add back up to 4. Minus 2 goes into 8 4 times. X comes out, so 1x stayed behind. Plus 2 goes into 4 twice. 1x came out, so that's where we got. All divided by 2x squared. The only thing I can cancel is whatever's been factored out, right? This 2 with this 2. 1x factors out, so 1x is left behind. I cannot cancel into those brackets. Do not cancel into brackets. So we are left with 5x cubed minus 4x plus 2, all divided by x. And I can't cancel into those brackets because then I'm splitting this up, and that's not allowed. It's illegal. Restrictions. Oops. Look at my denominator. X is the only variable down there. It's not adding or subtracting with anything, so x cannot be equal to 0. Okay, same idea. We've got a polynomial up top and down below. So let's factor each one. All right, I'm just going to write it over here. So we've got f of x is equal to x squared plus 7x minus 8, all divided by 2 minus 2x. So we factor the numerator separately. We factor the denominator separately. So let's do a quick little aside here. And I'm just going to look at the numerator. So my numerator is an x squared plus a 7x minus 8. So I need two numbers that multiply to equal my last, and then add to equal my middle. Not a lot of options here, is there? Looks like 8 and negative 1, because 8 minus 1 gives me 7. So because it's just a simple trinomial, we've got our x at the front of each bracket. One of the brackets gets your plus 8, and the other bracket gets your minus 1. Okay. How about my denominator? Let's look at it. So I have a 2 minus a 2x. Well, I've got a 2 is common to both. So that leaves me with a 1 minus an x. Now I'm probably going to want to cancel. So remember that little trick that we had where we common factored out a negative 1? Well, that's what's going to let me change things up. So if I take out a negative instead, that becomes a minus 1 and a plus x. Which means if we write it in the normal order of the x first, you get x minus 1. Yeah. We could have looked at that as 2 minus 2x. I could have just said, well, I'm going to write this in the order I'm used to. So negative 2x plus 2. And then I can see that I want to common factor out my negative 2. So I take that out. There's an x. Negative 2 goes into positive 2. Just like that. Okay. So regardless of how we looked at it, we still end up where we wanted. So that's good. That's good. All right. Let's finish this question. Let's see. My function can be rewritten as my numerator we factored out. So we've got an x plus an 8. and an x minus a 1. And our denominator, we common factored out that negative 2. And we're left with an x minus a 1. Look for full bracket, a full bracket. Let's see, x plus 8. No other x plus 8s. X minus 1. Oh, I found an x minus 1. Okay, so that means I'm allowed to cancel those because they are the same. So I'm left with x plus 8 up top and a negative 2 down below. Let's think about our restrictions. So we look at our fully factored denominator. That said x minus 1 cannot equal 0, which means x cannot equal positive 1. So let's just look at the way they worded the question. State the domain. Well, stating the domain just says x can be any real number, and then we put in our restriction. X cannot equal negative 1. Done. Good. Phew. We're getting there, folks. One more example. Let's do one more example here. Okay, so again, we've got stuff happening in that top. We got stuff happening down below. But we got some factoring skills. We can handle this. All right, let's look at my numerator. Let's just do some factoring to begin with. So let's look at our numerator. So my numerator has a 4x squared minus 16y squared. Two terms, minus sign in between. I don't know why that link keeps showing up. Sorry. Well, if I take the square root of 4x squared, square root of 4 is 2, square root of x squared is x. If I take the square root of 16y squared, well, the square root of 16 is 4, square root of y squared is y. Oh, I have a difference of squares. Yes. Good. So the whole thing is equal to, open a bracket, right? We got two sets of brackets. 2x is in the start of both of them. 4y is at the end of both of them. One of them gets a plus, one of them gets a minus. Nice. Okay, let's look at our denominator. And here I've got an x squared no, that's a plus xy minus 6y squared. Three terms, trinomial. There's no number in front of the x. Okay, so here we're looking for two numbers that multiply to equal our last, which is the negative 6, and the two numbers that add to equal the middle, which is, well, there's nothing there, so it's a 1. Okay, I'm ignoring my letters for a second here. What two numbers multiply to 6 and add to 1? And not a whole lot of choice here. We need a 3 and a 2 to multiply to 6, and if I make the 2 negative, opposite signs gives me a negative answer, and 3 minus 2 gives me 1. Okay, good. Now then, if I look at my letters, let's see, I've got an x squared and an x, and a y squared and a y. So that's fine. So that means when I go to factor this, I have an x at the front and a y at the end of each of my brackets. And then let's put in our numbers. So this will be the plus 3, and this will be the minus 2. So then when I go to expand it out, now if I went to go expand it back out, I would get x squared times negative 2xy, and then this would give me a plus 3xy, and this would give me a minus 3 times 2 is 6. Y times y gives me y squared. So if I expanded it back out, I do end up with exactly what I started with. Good. Self-check. We got it. Yay, go team. Okay. Now let's go back to the question. Simplify and state any restrictions on the variables. So the question was 4x squared minus 16y squared, all divided by x squared plus xy minus 6y squared. So then let's put in our factored forms. So I've got a 2x plus 4y up top, and I've got a 2x minus 4y, all divided by x plus 3y and x minus 2y. Okay, let's factor. Okay, let's see. 2x plus 4. Oh, I don't have any down there. 2x. I don't have any down there. Well, I can't factor. Oh, but what do you notice? Can I continue to factor up top again? I can. I've got a common 2 in each one. I missed my common factor. That's okay. It's okay if you don't get it always right at the start. That's okay. So I could have common factored it right at the start, for sure. But I didn't. I missed it. So you know what? Let's do it now. I can take a 2 out of this first bracket, x plus 2y. I can take a 2 out of the second bracket, and that gives me an x minus 2y. All divided by, I haven't done anything to the denominator, but since I didn't do this as an aside, I'm going to do it all together. 2 times 2 is 4. We'll put that out front. And then that gives me my x plus my 2y, x minus 2y, all divided by x plus 3y, x minus 2y. Do I have any that cancel? I do. Let's highlight them up. I like highlighters. So I have an x minus a 2y, and I have an x minus a 2y. So those ones that can cancel. I have, where's another color here? Come here. What's going on? I have an x plus a 2y, and sure, an x plus a 3y. So I can only cancel ones that are the same. And once it's canceled, it's gone. Oops. So I can cancel out this one and this one, but nobody else. So I'm left with a 4 bracket x plus 2y, all divided by x plus 3y. So I'm done. Woo! Don't forget our restrictions. So we're going to look at our fully factored denominator for our restrictions. I have an x plus a 3y, which cannot equal 0. And I have an x minus a 2y, which cannot equal 0. So that means, let's see, x cannot equal 2y, and x cannot equal negative 3y. And as far as we go, that's as far as we can go with our restrictions. So give some questions a try. See how it goes. I do like highlighting to help emphasize the fact that the brackets are one piece and they have to travel together. Good luck.